What is up, guys? This is Luke Hill for Kit Guru, and this is the Gigabyte TRX40 Aorus Master. This is an STRX4 motherboard, reasonably priced at about £500 in the UK, packed with a lot of features, and equipped with an absolute beast of a power delivery solution. So let's take a deeper look into it. Firstly, what you can see in front of me is the accessory bundle. So we've got a bunch of cables, the usual affair, so SATA cables, RGB extension cables, you've got a quick connector block, you've got stickers, you've got additional stickers actually, so a lot of those, instruction manual, the antenna for the Wi-Fi, because this motherboard does have Wi-Fi, and then you've got a pretty cool cable here. So this is basically a noise pressure sensor cable. So Gigabyte has a feature whereby the motherboard can detect noise level of your system based on fan airflow. It doesn't actually listen to you, thankfully, it's detecting pressure, but that's quite a cool feature. So that's the accessory bundle. I'm gonna leave it on the table so we can see exactly what's included. And now we're gonna look at this thing. If I just pick up the TRX40 Aorus Master, first and foremost, we can see primarily black styling. Obviously you've got silver accents where you've got the steel accessory bits and the stiffeners for the DIMM slots and the PCIe slots primarily. What you will notice straight away is that, personally what I noticed actually, is that it's a good looking motherboard. It's got a lot of angular appearance, pretty heavy when you pick it up. And when I say pretty heavy, I mean heavy. This is a heavy motherboard. There's a lot going on, a lot of cooling on there. You will also notice that it's eATX in form factor. So you've got the standard length, but it's wider than normal. And this can cause a challenge with a lot of cases. Granted, if you're buying the TRX40 platform, you're probably going to have a high-end case which can take an eATX, a wider than normal motherboard. However, this right angle 24 pin, that's a bit of a problem. If we move along to the back side of the motherboard, what we can see is a solid metal. This is an aluminium backplate. This does actually make some contact with the back of the PCB behind where the MOSFETs are mounted, so it's doing some cooling. It gives a lot of stiffness to the motherboard, which is especially useful if you're mounting a big, heavy air cooler on the front side. And Gigabyte says this is nanocarbon coated, and that's just fancy naming, quite frankly, because it's quite a common process in industry. It should help with some of the thermal properties. Realistically, it's going to help the stiffness, and it will help the thermal properties of the motherboard power delivery solution, because you've got a big bulk of metal drawing away some of the heat. Pretty cool. In terms of DDR4 memory support, we've got the standard 8 DIMM slots. Of course, these are DDR4 quad channel because it's TRX40 Threadripper 3000 platform. If you're going to install standard 32GB DIMMs, then you can get up to 256 gigabytes and you get high speed capability. And Gigabyte does outline some support for ECC memory, so specifically from vColor and Crucial. So you can look into ECC if you want to run a server or something like that on a workstation on this motherboard. That's good to see, but your mileage may vary with what the compatibility is there. Sticking with the DIMM and CPU socket area, of course, we've got the absolutely massive STRX4 CPU socket, but what you will see is that Gigabyte's using the standard vertical positioning of the STRX4 socket and the DIMM slots, and that means that the first PCIe slot is infringed upon, so you're basically going to run your graphics card in the second slot, so you don't get the full whack of PCIe expansion slots. But this should help move some things down from the top of the motherboard. ASRock's TRX40 Creator is an alternative approach here, which has some pros and cons, but you will need to watch out for CPU cooler interference if you're using a big air cooler with a graphics card with a backplate. Worth watching out for, but certainly less of an issue than some of the competing motherboards that use the top slot for Threadripper. What we see in the top right corner is what I like to see from a motherboard of this ilk. What we can see here is a bunch of buttons, headers, switches. We've got the 2-digit debug LED, which I absolutely love to see on a motherboard of this caliber. Power button there, that's really good for testing outside of the chassis. We've got some switches that can control the dual BIOS mode, because Gigabyte does give you 2 BIOSes, one of which is socketed, so you've got a lot of redundancy and resiliency there. Fantastic to see. I like Gigabyte doing this. Very, very good to see. You've got both 8-pin power connectors up in the top right, and this is a bit of an unusual location for them. We usually see them in the top left. I'm not against it because cable management is what I would call easy enough because they're near the edge of the board, but for some people who've already routed around this top left positioning for the 8-pin, it might be a bit of an inconvenience in your first installation. Moving down to the 24-pin area, as we already highlighted, it's right angled in orientation, but Gigabyte does take a rather sizable notch out of the motherboard PCB to allow for some accessibility to the 24-pin. So depending on your chassis, this could be a really cool feature, a really good feature that helps your cable management, or it could be a complete pain. You have to basically understand what your chassis is going to do with regards to interference, and then deal with it. If it's going to be a problem, then you have to find a way to deal with it, whether that's an extension cable or whether that's perhaps looking at a different chassis or a different motherboard. Quite frankly, there's not much you can do to avoid using the 24-pin. Somewhat unusually for a standard motherboard these days, we've got the front panel connectors up in this location near the 24-pin. Perfectly fine in my opinion, because they're along the board's edge, so it's still perfectly easy to hide the cables. In fact, it's perhaps easier than putting them in the bottom location, because if you've got slightly shorter cables with your case, far easier to reach. And then moving down, we've got the internal USB 3.2 Gen 2 Type-C connector. I would have liked if Gigabyte pushed this a bit closer to the edge of the motherboard, but the internal connector used from one's chassis is very limited in flexibility anyway, so it's not a really big deal, to be quite frank. All 8 of the SATA 6 gigabits per second ports operate from the TRX40 chipset, and they do not share bandwidth with anything else, so you can put heavy, fast SSD arrays on here, no problem whatsoever. If we look at the bottom edge connectors on the TRX40 Aorus Master, they're slightly different to usual because we've got the front panel connectors up in the top right location. So if I lift up the board, and just to re-emphasize, this is a heavy board, there's a lot of heatsink on here, a lot of metal, and the backplate is pretty solid too. What we can see is you've got a bunch of fan headers, and Gigabyte deserves a lot of credit here. You've got 2 fan headers over in the bottom right location and 3 kind of centrally in the bottom edge location. But these are ideal because they allow you to tuck away the cable very, very easily. You get 2 internal USB 3.0, or if you prefer 3.1 Gen 1 or whatever other stupid naming they're using these days. They're 5 gigabits per second internal headers, so they're ideal for your chassis. And then good thing to see is 2 USB 2 internal headers. This is good because obviously, as we know, RGB controllers, AIO pumps, cases, they all need USB 2.0 still. So having 1 is just not enough in my opinion. 2 is fine, but not ideal, but 2 is good to see. Back along on this side, that's where you get the sound connector header for Gigabyte's sound connecting or sound detecting cable if you prefer. And like I said, it's not actually listening to your audio, it's basically a pressure sensor. Focusing now on the expansion slots, if we primarily look at the full length slots, we run these in X16, X8, X16, X8 mode, and they're fed with PCIe Gen 4 lanes from the Threadripper 3000 CPU. So if you want a multi-GPU setup, obviously you can do 2 triple slot cards, no problem, or you can do a larger array of dual slot cards if you're happy to run one of those cards at by 8, and if you want some cooling gap. There's a good amount of flexibility with Gigabyte's layout here is what I'm trying to say. The PCIe by 1 expansion slot is closed off, so just a by 1 adapter in here. So maybe, I don't know, if you've got a legacy SATA adapter for some reason, you can chuck that in there, sound card or whatever. And this runs from a PCIe Gen 4 by 1 lane from the TRX40 chipset, so nothing high bandwidth going through there. What I will say about Gigabyte's expansion slot layout is it's preferable to its competitor, the Asus TRX40E gaming motherboard, because there's a bit more flexibility for multi-GPU users in this configuration. So credit to Gigabyte there for deploying what I would call a pretty sensible expansion slot layout approach for an enthusiast gaming grade motherboard for this platform. You get a total of 3 M.2 slots on the motherboard. So the one at the top is underneath its own dedicated heatsink, and then if I lift this up, you've got 2 at the bottom which share a heatsink. Now we've seen Asus go down the heatsink sharing approach with its TRX40E gaming competitor, and I'm kind of in 2 minds with this. If you're installing 2 SSDs and you're sharing a heatsink, they're going to share the thermal load between them, so you could elevate the temperature of one SSD if the other one's running hot. Of course that reduces its temperature, but they have an interaction with each other which could be good or could be bad depending on your use case and your workload. If you're running one SSD under a heatsink designed for 2 SSDs, that is a good thing. You're giving it more surface area, more cooling capacity, so certainly no complaints there. I must credit Gigabyte with its heatsink approach. It's very easy to install, so unlike some of the other motherboards that we see, primarily with X570 and Z390 if I'm being honest, but there's no kind of all motherboard shroud at the bottom that you have to remove a bunch of screws and then install the SSD. There's simple heatsinks, 2 screws, install the SSDs, peel off the sticker, put them back down. Very, very simple, provided you're happy to move a graphics card if you've already built your system. The top slot is fed by the CPU itself, as is the center lower slot, but the lower right slot is actually fed by the TRX40 chipset. Fundamentally, this doesn't make too much difference because they all support PCIe Gen 4 by 4 SSDs as a maximum bandwidth, or SATA SSDs if you prefer. It just depends on how much data you're pushing through that pipeline between the CPU and the chipset. The amp-up audio solution that Gigabyte deploys is based around the Realtek ALC1220 audio codec, and this is very common. We see this quite frequently, especially on these Threadripper motherboards. A Realtek 4050H, or 2 in fact in this case, USB bridge chip is used to convert one of the USB connections to a HD audio capable connection. You also get WEMA audio capacitors and an ESS DAC. Moving around to the rear I/O, we get a rather good selection of ports. So first and foremost, you've got your clear CMOS, which I love to see on the back, and I'd say this is probably fine for not being accidentally pressed. Its location is pretty good in my opinion. You got a Q Flash Plus, which is Gigabyte's BIOS flashback mode, good for upgrading if you use a future potential Threadripper chip with this motherboard and it hasn't been updated in a while, and then you've got a dedicated USB 2 connection for which you can use with that. You've got another USB 2 connection, so 2 in total, and then you've got some higher speed USB connections along the back of the motherboard, and of course you get your typical Type-C, so 3.2 Gen 2, 10 gigabits per second. No 20 gigabits per second USB Type-C on this motherboard, but given the enthusiast kind of gamer and overclocker and not heavy content creator market that this motherboard's going for, I don't see that as a major downside, quite frankly. One of the other clear positives is the networking capability. So you've got 802.11ax Wi-Fi, so that's based off an Intel chipset for the wireless, and that's very fast, up to 2.4 gigabits per second. You've got a standard 1 gigabit Intel, which is, like I said, 1 gigabit i211AT, very robust, resilient NIC, and then you've got a 5 gigabit Aquantia NIC. And that's good to see because, in my opinion, we should be going past 1 gigabit on the internal network at this point, especially for high-end motherboards like this. And then rounding out the rear I/O, you've got the standard affair of audio connectors, and Gigabyte actually used some gold plating for the analog type jack, so no problems there. Of course, you've got the integrated rear I/O shield, which is another premium touch on a motherboard like this. Good to see. 500 quid is certainly not too much to ask for. And you've got some venting, which allows air to be drawn into the VRM cooling fan. In terms of fan headers, we get 8 in total, and 3 of these are within easy reach of the CPU socket, and they're all positioned along the motherboard's edge or close to the CPU socket, therefore cable management is a positive. Gigabyte deserves a lot of credit for its fan control system on this motherboard. So these hybrid headers actually support a higher current than is normal, so you support 2 amps or 24 watts, so you can drive either really high powered fans or water cooling pumps, for example. And the UEFI and OS software control is superb. I would actually go as far as saying that Gigabyte Smart Fan 5 control system is the best on the market, even better than Asus's fan control system right now. And go over to the Kickr website and check out the main article with screenshots of the UEFI to see why that is the case. Good job, Gigabyte. The fan control on this board is fantastic. Excuse the pun. I think one of the other key points with the fan control system is that you get plenty of sensors to feed temperature data through to those fan curves, and you actually get 2 external temperature sensor headers, and these are included in the bundle. So if you want to record the temperature from a specific location and drive a fan based on that, you can do it. You can do it twice over. And then if you're into RGB, of course, you've got the onboard RGB, which is rather subtle, but looks pretty good. And then you've got 2 headers down the bottom and 2 headers in the top right. One of each is an addressable type header. Gigabyte's power delivery solution for the TRX40 Aorus Master is a beast. Quite frankly, it's just as simple as that. It is an absolute monster. First and foremost, it's controlled by the Infineon XDPE132G5C. What an awful name. I'm sorry. I mean, I know there's an engineering term in there and they probably named it for a certain reason, but that does not roll off the tongue. But anyway, that's the controller, and this is the true 16-phase controller. So you do not see any phase doubling, even though this is a 16-phase solution. It's a real 16-phase solution. So you get the speed and latency benefits of real control phases, and you get the fat 16-phase capacity benefit of doublers. So it's basically not doublers, not using doubling, but you get the best of both worlds because you're using such a high-end PWM. The 16 power stages, each of them are international rectifiers, TDA 21472 power stages, so those co-packaged solutions are rated at a theoretical maximum of 70 amps. That gives you 1120 amps of current capability, theoretically, to an STRX4 CPU. So even if you push in the 64-core 3990X hard, and I mean hard, you're not going to sweat this power delivery solution, provided you can cool it well. This is, at £500, an absolute bargain of a power delivery solution, quite frankly. It's better than everything else at this price point. Even Asus's competing solution is using 60 amp power stages rather than the uprated version, which is 70 amps. So power delivery solution, Gigabyte has absolutely nailed it. And then if the 16-phase solution for the CPU is enough, you get a 3-phase SoC power delivery solution. Overkill at its finest. Now the primary MOSFET heatsink is mounted at the top of the motherboard, and it connects via a heat pipe to the secondary MOSFET heatsink and also this slab of metal down the bottom which acts as thermal capacitance. I'd say Gigabyte's overall cooling design for the VRM is strong. You get a good degree of fins in the heatsink. Actually, it's a finned heatsink. It looks like a proper heatsink rather than just an aesthetic slab of metal that looks cool. And it connects via heat pipe to increase the surface area. One of the challenging points though is that the fan is mounted directly by the left side heatsink, and the 30mm fan is quite small, has to spin pretty fast in order to move any sufficient flow of air. The fact that the fan is mounted on the left side heatsink, where the bulk of the heat source is coming out of the top side heatsink, that creates a bit of a challenge because you will get a lag time from the cooling benefits of the fan compared to the thermal load being put through the top side heatsink. So not ideal, but I can see why Gigabyte has gone for this approach in order to maintain a low profile and intrusive heatsink that should minimize interference with roof-mounted AIO coolers or large CPU air coolers. It's significantly shorter than the ASRock competing solution at this price point that we saw in the TRX40 Creator, and it's far less bulky than Asus's TRX40E gaming solution. However, the Asus solution is quite a strong competitor, even compared to this Gigabyte one when it comes to thermal performance. So overall, I'd say the heatsink is very effective, and our testing does show that, so spoiler alert for the rest of the review. But being finned, it's more balanced for really heavy thermal loads where you can flush that heat quite effectively. The challenge with flushing that heavy heat load effectively is that the fan is not in the ideal position, in my opinion. On the topic of MOSFET fan, this 30mm unit can spin up to 10,500 RPM, at which point it sounds like a dentist drill and feels just as horrible as you can imagine. It's a bit more reasonable when we're running at sensible speeds, at about 5,000 RPM, which it tends to like on the default modes. It's audible, it's somewhat intrusive if you've got a quiet CPU cooler, but it's not pull your hair out annoying, shall we say. If you want to use a control curve to manage it, you can, thanks to Gigabyte's excellent control in the UEFI and in software, and we managed to push down to about 4,000 RPM while maintaining temperatures below 70 degrees Celsius that we were perfectly happy with. We could have been even more aggressive if we were happier with higher temperatures. And then moving down to the chipset fan, this is a 55mm unit and it uses vertically mounted fan blades so that you can direct the airflow in a specific orientation. This one's not too loud, to be honest, in the default mode. I'd say the default mode's a bit inefficient because the temperature is very good when the fan is spinning, so therefore it's spinning faster than it needs to. And with a quiet CPU cooler, you can just about hear it. But again, the actual heatsink itself is well built, it's solid metal, it feels sturdy, it does a good job of cooling, and you get excellent control in the UEFI. So kudos to Gigabyte there for the chipset fan. Anyway, that's the closer look at the motherboard. We probably spent way too much time on that, so let's jump into the performance figures. But first of all, the test system. Our TRX40 motherboard test system uses AMD's 3970X CPU. This 32-core beast and its ample connectivity and 280-watt TDP should stress even the high-end motherboards on this platform. Memory comes in the form of a 4x8GB kit of 3200MHz C14 G.SKILL Trident Z RGB DDR4. The Samsung B-die ICs under the hood still prove their worth, even though Zen 2 is a good match for more expensive 3600 C16 modules. CPU cooling is handled by the Cooler Master Wraith Ripper. We specifically use this air cooler as it has a TR4 sized contact plate, and our own testing has shown that cooling Threadripper's large heat spreader can cause cooling challenges with smaller AIO cold plates. Pixel pushing power comes from Gigabyte's beastly Aorus RTX 2080 Ti XTREME graphics card. This triple slot monster pushes the GPU performance to a level where we can identify differences between competing solutions. We use a custom fan curve to minimize thermal throttling and ensure consistency between test configurations. Power is delivered by the new Seasonic Prime TX1000 80+ titanium rated PSU. This 1kW beast serves up clean power and a pair of 8-pin CPU connectors that are ideal for our overclocking stress tests. If you want more details on the UEFI and the OS software, make sure you head on over to the KitGuru website, where you'll find also more details about the test system, the comparison points, and the software that we use. We were using the latest BIOS revision at the time of testing, which is F4H, and that uses the G7 1003 profile. CPU performance from the Gigabyte TRX40 Aorus Master was as good as competing TRX40 motherboards, if not a little faster, albeit with minor victories. All-core frequencies were around 3.875 GHz in Cinebench R20 NT, while the single-threaded test confirmed that the maximum boost clocks of 4.5 GHz were being achieved. Blender also showed perfectly competent performance from the Gigabyte motherboard, with its results matching those of Asus and ASRock competitors. All-core frequencies in Blender hovered around 3825 MHz on average. Gigabyte's board is as fast as competitors in terms of 7 zips decompressing numbers, but it is noticeably slower on the compressing front. This is an early indicator that the system memory bandwidth is reduced versus the competing solutions, as it is a critical factor in 7 zips performance. Gigabyte's memory bandwidth scores register a little higher than the ASRock and Asus competitors in AIDA64, especially when focusing on the read result. However, when we switch focus to SciSoft Sandra's test, we see the Gigabyte board drop to the bottom of the chart. This looks to be a key explanation for the lackluster 7-zip compression performance result. The AIDA64 memory latency test shows no real cause for concern from the TRX40 Aorus Master. The margins in gaming performance between all motherboards are slim, but Gigabyte does consistently outperform its competitors by small, repeatable amounts. This is most notable in Shadow of the Tomb Raider, whereby the TRX40 Aorus Master's average and 95% CPU FPS values are chart topping. You shouldn't expect to put yourself in a new tier of gaming performance using the TRX40 Aorus Master. However, the game results we have seen are repeatably strong from Gigabyte's offering. M.2 performance is close to where we would expect it to be, with the PCIe Gen 4x4 SSD peaking at just below 5 GB per second. Cooling performance from Gigabyte's M.2 heatsink was reasonable. We observed the drives operating around 63 degrees Celsius in our Crystal Disk Mark benchmark run, even when our OS SSD was installed under the same heatsink. No problems to report with SATA performance. We do not see any reason why users should have concerns about deploying an army of SATA SSDs. Rightmark Audio Analyzer rates the Gigabyte TRX40 Aorus Master motherboard's amp-up audio system as very good overall, with most of the categories actually scoring excellent. Gigabyte's UEFI and load line calibration is quite difficult to deal with because the values of high and extreme don't really mean anything. With that said, Gigabyte's graph does show quite nicely what these values should be doing, but based on our experience with competing motherboards from Asus and ASRock, and then moving along to the Gigabyte motherboard, we found that the voltage accuracy didn't really tie up with what we saw from those competing solutions, and this in turn took us down from our typical 4100 MHz overclock on the 3970X down to 4075 MHz stable with reasonable voltage, reasonable power, and reasonable temperatures. The problem from a voltage perspective really was to do with the motherboard's BIOS not retaining the settings during an overheat and then a BSOD or something like that, and a brand new post or new from dead boot, or sometimes even when the system was just powered down with the voltage levels and the 4100 MHz frequency, and then we booted it up into Windows, it wouldn't retain the setting somehow, and then we adjusted the frequency to 4075 MHz. This seemed to solve the majority of the issues, so that's what we settled on. It's disappointing that we had to reduce the frequency versus the competitors, but thankfully 25 MHz lower is not a massive deal. A performance boost of almost 750 points or 4.4% was obtained by overclocking the CPU to 4.075 GHz. This is not quite as fast as the 4.1 GHz overclock competitors, but it's close enough that many users will not be overly disappointed by the slightly lower frequency on Gigabyte's board. Gigabyte's stock voltage levels are sensible and the VRM solution is clearly very efficient, so stock clock numbers are reasonable as we would expect them to be. Overclocking increases the load power draw significantly, and our settings also pushed up the idle numbers by around 10%. In our testing, the 16 plus 3-phase power delivery solution had no problems dealing with this level of load. Gigabyte's VRM cooling solution does a stellar job at keeping the recorded temperatures in check. We saw the VRM sensor read and stay comfortably below 70 degrees Celsius at stock, but Gigabyte achieves this by using a relatively high fan speed around 5300 RPM. By comparison, the Asus TRX40E Gaming was able to stay at around 60 degrees Celsius MOSFET temperature without having to spin up its VRM cooling fans. We were able to reduce the Gigabyte board's fan speed to 4200 RPM while still getting 68 degrees Celsius VRM temperature readings, This was done using a custom fan speed curve that set the blower to 0 RPM until we reached 60 degrees Celsius. Gigabyte's superb UEFI fan control is to thank for this level of adjustment granularity. Overclocking did not add significant additional temperature or fan speed to the VRM cooling solution for short, bursty workloads. This implies that Gigabyte's heavily finned cooling design is efficient at shedding high heat loads, even if it does benefit from a decent amount of fan airflow at lower thermal loads. Chipset cooling was very good, and this is thanks in large to Gigabyte's robust chipset heatsink and the sizable fan. 2700 RPM fan speed that we recorded under this load condition was not audible over the higher speed VRM heatsink fan. If you're happy with chipset temperatures around the 70 degrees Celsius level, our test setup actually managed this with the fan operating primarily under its 0 RPM mode in complete silence, and that's a positive. I think we've already said plenty about the Gigabyte TRX40 Aorus Master motherboard. It's overall a very good motherboard, plenty of good features, some subtle annoyances, so EATX with the right angle 24 pin is going to cause a challenge for some people. The BIOS could do with a little bit more polishing, and the voltage accuracy compared to some of the other solutions wasn't ideal, so it takes a bit of getting used to. But overall, a superb motherboard. The cooling fan was perfectly adequate and tolerable from a noise perspective when we tuned the mode itself. The VRM heatsink did a perfectly stellar job at keeping temperatures in check, and overall the cooling capability, thanks to the Smart Fan 5 control system, is just fundamentally fantastic, I must say. If we look at some of the comparison points to the Asus ROG Strix TRX40E gaming motherboard, which is priced very similarly to this motherboard and is therefore a competitor, Gigabyte has some clear strengths. I think the expansion slot layout is better on the TRX40 Aorus Master, gives you more flexibility. Obviously you get the M.2 SSD approach with the dual sized cooling mechanism that we see on the Asus motherboard, so that's kind of a 6 of one, half a dozen of the other point. They're very comparable. EATX is a bit of a challenge here, like I've already mentioned a few times, but Gigabyte makes up for that with a solid backplate that is very sturdy and is really useful if you're hanging a heavy CPU cooler off and if you want to cool the PCB around the power delivery area. One of the other areas where Gigabyte does really well on this motherboard is using 5 gigabit networking. I think that's a really smart inclusion for a motherboard that people are likely to hold on to for a long period of time. I think it's about time we go past 1 gigabit in my opinion. One area, however, where Asus is particularly strong versus the Gigabyte Aorus Master is the VRM cooling. So even though Gigabyte's VRM is better and higher power and higher current capability on paper, and that's a fact, and it's using the superb Infineon controller, Asus has a slightly bigger heatsink, which is a hybrid type design, and it deals with those bursty loads a little bit better under kind of manageable lower load situations. I think if you're pushing maybe 600-700 watts through the 64 core, they're both going to be challenged and they're both going to have their fans spinning. But for the 32 core and about 280 watts being pushed to the CPU, Asus's competitor does it slightly better than Gigabyte's, but Gigabyte still does very well, quite frankly. And then some of the other beneficial points are you get plenty of fan headers, which is great to see. You get the temperature sensors, so you can drive custom fan curves very, very well. And like I said, the heatsink and the cooling is overall very good. You get a decent amount of RGB. It's just a good looking motherboard in my opinion. I also like the dual BIOS redundancy and the resiliency and the ability to switch between them. Overall, I mean, £500 is certainly not cheap for a motherboard. It's quite respectable for a TRX40 motherboard actually, but it's certainly not cheap. But I think Gigabyte does a lot of things well with the TRX40 Aorus Master, and I'm happy to give this a pretty strong recommendation. Make sure you read the written review too. I've been GH4 Cameras. Thank you for watching this review of the Gigabyte TRX40 Aorus Master motherboard. Let us know what you think in the comment section down below. Are you going to go out and buy this motherboard? Are you interested in something else? Are there any features you would be happy to see on this? Any features you don't particularly like? Let us know in the comment section down below. If you want more details, head over to the Gigabyte website where you can see the written review. And if you want to support us, make sure you check out our Patreon page, buy a cool t-shirt, give us a like and a subscribe. See you next time.